Have you ever been so stuck on a problem that you just wish you knew the answer? Well, what if I told you that sometimes the fastest way to get to a solution is to start by, well, guessing the answer? Today we're going to dive into this really cool kind of backwards thinking technique called binary search on the answer.
So, let's kick things off with a classic puzzle to wrap our heads around this. Imagine you've got a bunch of cows, and you need to place them in stalls along a barn. Your goal is to maximize the minimum distance between any two cows, so they all have their personal space. Now, you could try to check every single possible arrangement, but that would take practically forever. There's a much smarter way to do this.
So here's our game plan. We'll start with that aha moment behind the puzzle. Then, I'll give you a 3-step blueprint you can basically copy and paste for these kinds of problems. After that, we'll see how this pattern shows up in all sorts of unexpected places. And finally, we'll talk about how to really make this way of thinking second nature.
All right, let's get into the core idea. The real magic here isn't about some complicated formula, it's about flipping the problem on its head.
This right here is the big secret. Instead of trying to calculate the perfect distance, we're going to change the question. We'll just pick a distance, let's say 10 feet, and ask a much simpler question. Is it possible to place all the cows at least 10 feet apart? See what we did there? We turned a really hard optimization problem into a simple yes or no question.
Now, if this feels a little familiar, it should. It's basically the same logic as the Guess My Number game. Where you guess 50 and I say higher, so you know to throw away all the numbers from 1 to 50. We're doing the exact same thing here, but instead of searching through numbers in an array, we're searching through all the possible final answers. Our simple yes or no check tells us which half of the answers we can just toss out.
The reason this guessing game works so well is because of a special property called monotonicity. It's really just common sense. Think about our cows. If you can place them 10 feet apart, then you can definitely place them 9 feet apart, right? And if you can't place them 20 feet apart, there's no way you're going to place them 21 feet apart. This predictable relationship is a secret sauce that lets us confidently chop our search space in half with every single guess.
Okay, so that's the theory, but how do we actually turn this into code that works? Well, it all boils down to a super simple, reusable blueprint.
It's really just these 3 steps. First, you define your search space. What's the smallest and largest possible answer you could ever have? For the cows, the minimum distance could be 1, and the max is just the distance from the very first stall to the very last one. Easy. Step 2, you run a standard binary search on that range. And step 3, this is the heart of it. You write a little helper function. This function takes your guess, or mid, and just returns true or false. For the cows, you just greedily try to place them. You stick one at the start, then walk down the line and place the next one as soon as you find a stall that meets your distance guess. If you can place all the cows, it returns true.
And here's what that looks like in code. It's a pretty standard template. You set your low and high bounds for the answer, you loop, you pick a middle value to test, that's your guess, you pass it to your feasibility function. If it returns true, awesome. That means your guess is possible. So you save it as a potential answer, and then you try for an even better one. If it's false, well, your guess was too high and you have to aim lower. That's it.
And the real beauty of this whole thing? It is incredibly fast. Instead of that brute force approach that takes forever, you're now doing a tiny logarithmic number of checks. The total time complexity is just the time it takes to run your check function multiplied by log of the answer range. It's a massive speedup.
Okay, so once you get this blueprint down, you're going to start seeing it everywhere. Let's look at a few famous problems that are actually just this exact same pattern, wearing a different costume. Take Koko eating bananas. The problem asks for the minimum speed Koko needs to finish all the bananas in a given time. So instead of trying to calculate the speed, we just binary search for it. We guess the speed, say 10 bananas per hour, then we check. At this speed, can she finish on time? It's a simple yes or no.
How about this one? Split an array into pieces to minimize the largest sum of any one piece. Now listen to those keywords, minimize a maximum. That is a huge giveaway that this pattern might work. We just binary search for what that maximum sum could be. Then we check, is it possible to split the array so that no single piece has a sum greater than our guess?
It's the same idea all over again. You need to find the minimum capacity a ship needs to deliver all packages within a certain number of days. Don't calculate it, just binary search for the answer. Pick a capacity and check. With a ship this big, can we get everything delivered on time? It's the same fundamental logic every single time.
All right, you've seen the theory and a bunch of examples. Let's wrap up by talking about how to actually put this into practice and, more importantly, what pitfalls to avoid.
These are the classic mistakes that everyone makes at first.
Getting your loop conditions off by 1 can send you into an infinite loop. Calculating your middle point as low plus high divided by 2 can actually cause an integer overflow if low and high are huge, which is why low plus high minus low divided by 2 is a safer bet. And of course, the biggest one, if the problem doesn't have that monotonic property we talked about, the whole strategy falls apart. So always take a second to confirm that first.
Look, the only way to really get a feel for this is to practice. Start with some of the more straightforward ones like Koko eating bananas to really nail down the template. Then you can move up to the problems we've talked about, like aggressive cows. And once you're feeling really confident, you can challenge yourself with advanced problems where figuring out the check function is a puzzle in itself.
So, here's what I want you to take away. The next time you're faced with a problem that asks you to find the best, or smallest, or largest possible something, just stop for a second. Ask yourself a different question. If I already had the answer, could I check if it's valid? If the answer to that question is yes, then you might have just found a massive shortcut to the solution.